last time, there's no way to just dim the lights here. And if I turn the lights off, it's hard to take any notes if you wanted to take notes. And for the camera, it may work better with the lights on. So I'm going to try leaving the lights on and see if the slides are bright enough that we can show lots. Mike mentioned the volunteer requirement, and we do ask that you give, I remember whether they said 20 or 30 hours of volunteer service to get your Master Naturalist patch. And that can be in any number of ways. It can be guided walks, it can be habitat restoration, things like that. I don't know whether a trash cleanup would count, but I guess any kind of volunteer hour. You show up at Public Lands Day where you wouldn't have shown up otherwise. You know, you don't have to be a Master Naturalist to do that, but we do need more volunteers, and so I'm willing to be pretty liberal about what I accept as volunteer hours. Doesn't have to be done by any particular deadline. Certainly, I don't expect people to do it by the end of the class. Just when we finish the class, let me know what you're doing and who you're helping. But I want a chance for the folks to really give back to the program. So, yes? How many hours? 30.
And was this done in Cochise County or Santa Cruz? It's okay.
No, Santa Cruz would be all right. Yeah, okay. Yeah.
And it seems to me it said something about you would get your $100.
Well, that's only if you volunteer for the Friends of the San Pedro, because that money is coming from the Friends of the San Pedro. So, well, we're gonna have a board meeting and make sure of that. We did it last time, although we only had one person take us up on it. We can't give the money back to everybody in the classroom, but one or two we may be able to do.
So, I was looking at membership. Are we members of anything?
Nope.
Okay, so
Nope.
to be a member of like SABO or something like that.
That's a separate thing. Yeah.
Okay.
Yeah.
Are you aware of any volunteer opportunities like the Mountain Lion County and that kind of research stuff?
Yeah, you know, the Sky Islands Alliance does some tracking work and tracking workshops. That would count, those sorts of things. So yeah, any sort of work. So we're starting off, you know, the schedule of classes there looks like kind of a jumble, and you would think that we would want to start off with the very basics, start off with rocks, do geology, and then weather, and maybe hydrology, and then move to plants, and then to insect, and go taxonomically up the list and all. But really, ecology is what ties it all together. And I'm hoping that over the next 11 weeks, you're going to get reinforcement on a lot of the things we talk about today. You're going to hear from the insect people and the plant people and the bird people about concepts that we talk about tonight. So I just wanted to give a basic grounding in ecology. Many of you have already had these terms in your classes, have biology degrees and things like that. Some of you haven't, so I'm gonna don't be insulted if I go very basic at times. But we just want to talk about what ecology is and how things kind of fit together. I did notice when I looked at the Texas curriculum, they spent a whole class period talking about taxonomy and the history of taxonomy, basically naming things: kingdom, phylum, class, order, family, genus, species. And in fact, this is the way I learned it when I went to school back in the late Pleistocene. They have added things since then. There are new things added. This is the mnemonic that we learned so we could keep up with kingdom, phylum, class, order, family, genus, species. But now they've added two new things up here. There are new life forms being classified that we didn't even think about 30 years ago. In fact, this wasn't until the 90s that they added domain. So we added a couple of things to the mnemonic over there. But the taxonomy, knowing the kingdom, phylum, class, order, genus, species, is probably the least important thing about an organism. If you've ever been on a guided walk where they walk down the trail and call off the scientific name of every plant along the way, you fall asleep about 50 yards down the trail. That's the least interesting thing. And we're not even sure, I mean, we want to shoehorn things into categories. We want nature to be digital. We want it to be either this or that. And nature is not digital. Nature is analog, and things move and things change. You can get an argument just about what a species is. But looking at a bear, starting out with the domain, it's a creature that has a membrane around its cell. So it's with all these other things. It's an animal. It has a backbone. It has hair. It eats meat. It has the dental formula and the size of all the other bears, including things like pandas that are not really true bears. Get to the genus, now you're talking bear, and the species, Ursus americana. So this is just a way of narrowing down, starting with a very broad classification of everything that is alive and has a cell membrane, and working your way down smaller and smaller. That being said, we're not going to spend any more time on taxonomy. We're not going to worry about the genus and species of a lot of these things we're talking about. In particular, tonight, we're talking about processes, and we're talking about how things fit together. Ecology comes from the Greek word for house. It's a study of interactions among organisms and their environment. The way they interact with each other, and not just organisms, so the biotic and abiotic. And that's why, as we talk about this, we're going to be talking about the geology, the hydrology, the climatology. It all affects the wildlife, and it all affects the animals and plants, and how things all fit together. And it all goes together to make this area of southeast Arizona as special as it is. And that's some of the things we're going to be talking about tonight. I got a number of quotes thrown in here. Again, the weather is part of what makes this area special. Not only the amount of rainfall we get a little too much rainfall to be a classic desert. Desert is supposed to be under 10 inches according to all the classification. So we're not really classic desert. We not only get more than 10 inches, but the way the rainfall comes. If we got our 12 to 24 inches of rain, if we got an inch or two a month, it would be a very different place than a place that can go 6 months without any rain and then get a 3-inch downpour in an afternoon like we had last week. The monsoons really affect the way this area, the wildlife, has to interact. The geology, these mountains are perfectly designed for life. They've got this limestone cap, and so the rain and the snow that falls doesn't just run off right away. It soaks into that limestone. It makes caves like Carter Caverns, but it also seeps down through that limestone slowly, comes out of the side of the hill when it hits an impermeable layer and can't go down anymore, comes sideways out of the hill as a spring. And so that rain that comes 2 months out of the year gives us creeks like Ramsey Creek and Garden Creek and Soldier Creek that run all year long. It's just measured out over the whole year. So the geology very much affects what's going on here. When we talk about ecology, we're really talking almost as much a philosophy as we are hard science. John Muir said, when we try to pick out anything by itself, we find it's bound fast by 1,000 invisible cords that cannot be broken to everything in the universe. Everything's connected to everything else. And we're learning that more and more as we go along. There are connections that we hadn't even considered that we find out maybe we should have considered. And we'll talk about some of those instances tonight. Just in the diversity of life that's out there and trying to understand all the processes that are going on as we enjoy nature. Ecosystems may not only be more complex than we think, they may be more complex than we can think. They may be more complex than we can even comprehend, because the deeper we go, we're not finding the bottom. We're finding connections again. Even in the taxonomy, they're talking about whole magnitudes of living things that we didn't even think about 20 years ago. So there's a lot of complexity out there. I said we're not going to have a test, but I would like you to memorize this chart so that we can, I'll ask you about it a little later on. There's all these cycles going on out there. There's the water cycle, there's the nitrogen cycle, there's the carbon cycle. There are things happening with the sedimentary rocks. There's a lot going on out there. It's just so complicated that it boggles the mind to even think of it. And again, when we get back to the philosophy part of ecology, we always used to quote at Nature Conservancy, because we were in the conservation business, we said the first rule in intelligent tinkering is to save all the pieces. We don't know enough about how the world works to start discarding parts yet. And that's why endangered species are so important. I tell folks when we talk about endangered species, one of the ones I used to talk about was the lesser long-nosed bat, the nectar-feeding bats that we see here in southeast Arizona. And people say, oh, I'm in favor of saving whales and little bat and frog that's out there. Well, those nectar-feeding bats, besides visiting your hummingbird feeders, are pollinating the agaves. They're the primary pollinators of agaves, and always have been. And the saguaros. In the springtime, they come up and do the saguaros. In the fall, they do the agaves. If we didn't have nectar-feeding bats, we would not have agaves. If we didn't have agaves, we wouldn't have tequila. We wouldn't have margaritas. So it can hit you where you live. But actually, Paul Ehrlich, this is kind of a paraphrase of a quote from Aldo Leopold, who's kind of the father of ecology. And I've got this long-winded quote here, but it's just so beautiful, I had to put the whole thing on there. Harmony with land is like harmony with a friend. You cannot cherish his right hand and chop off his left. That is to say, you cannot love game and hate predators. You cannot conserve the waters and waste the ranges. You cannot build the forest and mine the farm. The land is one organism. Its parts, like our own parts, compete with each other and cooperate with each other. The competitions are as much a part of the inner workings as the cooperations. You can regulate them cautiously, but not abolish them. The outstanding scientific discovery of the 20th century is not television or radio, but rather the complexity of the land organism. Only those who know the most about it can appreciate how little we know about it. This was written in the 30s. And I don't know why he said land organism. Same principles apply at sea and in the water. The last word in ignorance is the man who says of an animal or plant, what good is it? I certainly agree with that. If the land mechanism as a whole is good, then every part is good, whether we understand it or not. If the biota in the course of aeons has built something we like but do not understand, then who but a fool would discard seemingly useless parts? To keep every cog and wheel is the first precaution of intelligent tinkering. So there's where that quote comes from Aldo Leopold's Sand County Almanac. I'll talk more about the Sand County Almanac in my mammal talk when we talk a little bit about wolves and Aldo Leopold's take on the wolf. But I just thought that was a beautiful way to talk about the way everything seems to be tied together. And one of the challenges of these classes, even though they're 3 hours long, every one of those classes we're having over the next 11 weeks is taught as a full semester or sometimes 2-semester course in college. Some of them are majors where you would, spend 3 or 4 years studying the geology of southeast Arizona, and we ask the instructors to do it in 2 or 3 hours. So tonight we're just going to hit the high points of ecology. We're going to talk about habitat and niche. We're going to talk about succession. We're going to talk about life processes, interactions, biodiversity, and the movement of energy through the living systems. So we're just going to hit the high points. The different types of interactions that plants and animals can have. Competition. You all kind of know what competition is. Predation. And then the symbiosis is 2 organisms working together. They kind of divide it out. Mutualism, they really need each other. They can't exist without each other. Commensalism, there's no real benefit to one of the partners, but one of the partners gets something out of it. And parasitism, one of the partners is helped and the other partner is hurt by it all. Competition basically says, and again, getting back to the real basics of habitat and niche, and this is something that you all probably understand. Habitat, in the most elementary of forms, habitat basically is your address, where you live, the habitat of the various plants and animals. And the niche is what you do. What do you do for a living? Where do you live? That's habitat and niche. And competition comes in when you've got a couple of organisms in the same habitat trying to do the same thing. And it just doesn't work. And generally, one of those species will decline or disappear. And you might think, well, gee, there's springtime, there's 30 species of warblers moving down the San Pedro River. How are they not in competition with each other? But the way they do it, they partition out those resources. One species of warbler feeds in the tops of the trees. Another species of warbler feeds in the mid-trees. Another species down at the bottom. They partition out those resources. I did a project down in Belize on a tropical field course, and my project was on the diversity of bats in the tropics. Again, there's 20 species of bats in the area where we were in Belize. How do 20 species of bats interact with each other? Well, they do it because some of them eat insects, some of them eat frogs, some of them drink blood, some of them eat other bats, some of them fly real low, some of them fly real high, some of them come out early in the evening, some of them come out late in the evening. They all kind of partition out the resources so that they're not directly competing with each other. Some species even avoid competition within the species. In some species, the male and the female are different enough that they don't compete with each other, so they can live in the same place and not directly compete with one another. It's a hard life out there, and you don't want to have to be competing with another species that may have some sort of advantage along the way. So competition very much drives what species are found where and what they're doing and what resources are available. Mutualism. One hand washes the other hand, and hummingbirds are kind of a specialty of ours, and the hummingbirds and the flowers have co-evolved. The deal that was struck, I'll give you high energy nectar if you'll carry my pollen to that next flower. And they have evolved along such that most hummingbird flowers are bright red. Hummingbirds see very well in the red spectrum. Which came first, the chicken or the egg? Hard to say. But hummingbirds are attracted to red. Bees don't see red very well. A bee flower tends to be white or yellow. Some of the moth flowers have very strong odors. Hummingbirds are not really looking for odors. They're looking for that red color. So this flower wants a hummingbird to visit it. And it's got its pollen right out here, so that when he sticks his beak in, he's going to get pollen right on his forehead. When he goes to that next flower, he's going to pollinate the flower. So this is a mutualistic situation here. The hummingbirds need the flowers need the hummingbirds. It all works out very well. Commensalism, again, back to the hummingbirds. It's a magnificent hummingbird feeding on a flower, and if you look very carefully, these little white specks are flower mites. They're not a parasite on the hummingbird. They're not going to stay on that hummingbird and suck its blood the way some mites might. They're a flower mite, and they're using that hummingbird like a subway car to get from one flower to the next. The hummingbird comes along, sticks his beak in the flower, and these mites come running up out of the flower up to the nostril. And that hummingbird flies to another flower 100 yards away, and the mites run out of the nostril and run down to that next flower. They're so tiny they couldn't travel to that flower on their own. They're not harming the hummingbird at all. He doesn't get anything out of this, but he's not harmed at all. But the mite is using the hummingbird for transportation. So this is an example of commensalism. The hummingbird doesn't seem to mind, and the mite gets a free ride out of it. Now, parasitism is the next one. And boy, I could show you some gross slides of parasitism. It seems like often when biologists get together, the conversation turns to parasites. But I chose to go with a nest parasite instead. We're not going to talk tapeworms and botflies. We're going to talk about nest parasites, and this is a species that's found on the river and really throughout southeastern Arizona, the brown-headed cowbird. A brown-headed cowbird, we say they're a nest parasite. That's because they lay their eggs in another bird's nest. Nice little nest here. You know, one of these things is not like the other. This cowbird has just dropped its egg in the nest and gone about her business. She's not going to raise that baby. She's going to let somebody else raise that baby. There used to be a theory that cowbirds did this. They used to be buffalo birds. Back when the herds of buffalo roamed the prairies, buffalo were always moving. The cowbirds couldn't afford to stay behind and raise a nest of birds because that herd would be long gone. So they just dropped their eggs along the way. There are a number of things wrong with that theory. There are other nest parasites around the world. In fact, the old world, the cuckoo, is a nest parasite in the old world, hence the term cuckold. Leaving your egg in another nest is just a good way to get out of having to raise your own young. Some of the cowbirds are a little more insidious than that. If this bird comes back and sees this egg is different and throws it out, the cowbird will come back and check, and if her egg's gone, she'll lay another one. And if it's gone again, she'll destroy the nest. Some birds will build another nest right over the nest with the cowbird chick in it or egg in it, and again the cowbird comes back and checks where she dropped that egg to make sure that her babies are being taken care of, even though she's not the one taking care of them. And here's two little baby Carolina wrens and their big ugly sister there. Here is a poor yellow warbler feeding what she must think is her grotesque offspring. The maternal instinct is so strong that these birds will feed anything that there are instances of birds feeding goldfish simply because the goldfish comes up and that bird sees a gaping mouth and her every instinct is to stick food in any gaping mouth she sees. But some of these parasites, nest parasites, take it to a whole nother level. Some of them, the lining of their mouth is very much like the host that they are parasitizing. So they are, if the parent tries to see that mouth and say, oh, that doesn't look like my baby's mouth, some of them do because they pick what species they're parasitizing. This is a real problem if you're a rare bird. If you're an extremely rare bird, a black-capped vireo or a golden-cheeked warbler in the Texas Hill Country, and there's only a few hundred pairs in the county, and those golden-cheeked warblers are raising cowbirds, that's a real problem. Here in Arizona, the southwest willow flycatcher. If all those southwest willow flycatchers are raising cowbirds instead of raising flycatchers, we've got a problem. So there have been control programs to trap cowbirds, to kill cowbirds. I have real ambivalent feelings about that. This is a native bird. This is not an invasive bird from somewhere else. This is a bird that belongs here. They just happen to be very successful at what they do. And we've made it easier for them. In pre-European times, the cowbirds would not venture into the deep forest. And so the deep forest birds didn't have to worry about cowbirds. It was the birds right around the edges that had to worry about cowbirds. And many of them developed defenses against cowbirds. They would throw the eggs out or they would throw the babies out. Now, those big forests are all fragmented. And some of those species that used to be in the deep forest are now finding themselves on the edge. They're dealing with cowbirds. They don't have any defense against them. And so the cowbird really takes advantage of the situation. It's not their fault. They're cowbirds. That's what they do. But it can be a real problem. And this, we'll talk today a lot about some of the game management and wildlife management, and the way it's hard to pick out. Here again, we're going back to Leopold. What good is it to choose sides and say, well, that's a good bird and that's a bad bird, and I don't like that bird, but I do like that bird? Just doesn't work that way. You can't love the right hand and chop off the left.
I mean, I know a lot of people how come over time by doing this, it's being raised by another species that has different habits and stuff. How come none of that transfers over, and changes?
They haven't. They've been doing it a long time, but they not long enough for really any sort of evolution. They're successful, and when you're successful, you keep on doing it. The amazing thing to me is, quite often a young bird or almost any species, they imprint very early. When they're first born, you raise a chicken under a duck, and he grows up thinking he's a duck. That was a real problem when they tried to foster the whooping cranes. They thought, oh, well, we'll put whooping crane eggs under sandhill cranes, and they can migrate with the sandhill cranes, and then we'll have another flock of whooping cranes. Well, those whooping cranes that grew up in a sandhill family, when it came time for them to choose a mate, they didn't know they were a whooping crane. They thought they were a sandhill crane. They tried mating and did mate with sandhill cranes. Ended up with whoop hills. So they imprint. But with cowbirds, it doesn't happen that way. This cowbird grows up with a yellow warbler mother, but when it comes time to mate, it looks for another cowbird. Yeah. So it knows, it's a successful parasite. And again, we have parasites living in and on us all the time. We also have lots of beneficial flora and fauna. We couldn't exist without the bacteria that live in our bodies. But parasitism is, one creature's benefit and the other suffers or doesn't.
So you can't judge good and bad, or you can't judge dangerous.
That's right. And that's where they draw the line, and it's, you don't want to lose that piece. You don't want to, you want to save all the pieces, and this is endangering those pieces. But we wouldn't want to wipe out the cowbirds either. They are a native species, so that's where it comes in. And sometimes, in the Pacific Northwest right now, they're talking about killing barred owls to save spotted owls. And it's, that's a management decision. Yes. Yeah. Yeah, Tina?
I was just going to ask about the coyote animal, how you go out, against that.
Well, we're going to talk about that a little later on. Predators are a really important part of the ecosystem, and they get the short shrift a lot. Yeah.
So, have they ever shown in history of raise in cowbird numbers over one species?
Yeah, they have increased over the years, but it's probably because of forced fragmentation more than anything else. There just have been very successful breeding because there suddenly are a lot more edges where they can come in contact. They're a bird of the open country. They're not going to go in the deep forest, but there's not much deep forest left in the east anyway anymore.
Have they found any certain species that the cowbird looks for to raise their young?
I don't know that. I don't know. I have to research that. Adaptation, the way a creature adapts, like the cowbirds, to its situation and where it lives. And I'll talk a little bit about some of the desert adaptations. Although, again, we're not in a true desert, but we don't get a whole lot of rain, and Arizona in general is not a real good place to be an amphibian. Amphibians need water for part of their life cycle, and water is at a premium here. Even our rivers are not much of a river, and our lakes less so. So what do? Well, if your couch is spadefoot toad, you wait for that first big rain of the monsoon. there's a big puddle out there that wasn't there the night before. You go out and join with another 100 couches spadefoot toads from the general area. Sounds like a herd of sheep out there. That first big rain of the monsoon, you just they all gather. They have a big orgy. They lay lots of eggs. They fertilize all these eggs, and that puddle doesn't have any fish in it because it wasn't there the day before. It doesn't have any turtles. It doesn't have any frogs. There's no predators there. It's a paradise, except that puddle's going to dry up if we don't get some more rain. So then it's a race. That puddle is getting smaller and smaller, and these frogs are in a hurry to get lungs. A species like the bullfrog will take over a year to go from an egg to a tadpole to an adult. The spadefoot toad does it in 2 weeks. They're on the fast track to get those lungs because they've got to get lungs before the pond dries up. The tadpoles normally feed on algae, but if the pond is getting very, very small and it looks like it might dry up, some of the tadpoles become cannibals. Their dentition changes, their digestive system changes, and they start eating other tadpoles. And because they're getting all that protein, they develop even faster. And the one research paper I read on this said that they eat other tadpoles, but they don't eat tadpoles from the same egg mass they came from. Now, I don't know how they figured that out, but they don't eat their siblings, evidently, but they'll eat everybody else. And they only do that if the pond is shrinking too fast. If you get rain again in a hurry, the pond gets big and they all make it. And the thing about this reproductive strategy, if you're successful, those 2 spadefoot toads can result in 10,000 little baby spadefoot toads. You may not be successful every time, but if you're successful occasionally and you have that number, there's going to be lots of toads out there. Yes?
Does that carry over, the speeding up that they develop so quickly, does that carry over to the adults when they don't have a very long life? Like a bullfrog over those several years.
I don't think so. No, I don't. I think once they're an adult, their metabolism is pretty well set. There was a frog down in Costa Rica, a toad actually, that had kind of the same lifestyle. First rain of the rainy season, the golden toads come out, lay their eggs, and then it's a race to see if those eggs can develop before the pools dry up. I heard a talk at a Herp Society meeting one time. It was one of the saddest talks I've ever heard. This woman was in Costa Rica studying something else. The first night of the rainy season came, she went out in the jungle, and there's these, tennis ball sized golden toads everywhere. She just fell in love with them. So she came back, changed her master's thesis, got some funding, got some graduate students. The next year she went back to Costa Rica. A big rain came, all the toads bred, and then there was no rain for about 2 weeks. All the puddles dried up, all the tadpoles died. The same thing happened the next year. And these toads only lived 2 years. So there were 2 years when they had 0 reproduction. No youngsters coming along. The adults died of old age. The toad is extinct now. And she was there to watch that. And I mean, this was her doctoral dissertation. She went back, the second year, and the rains come, and she searches and searches and searches, and there's no toads. And that's an example of how these abiotic things, how the weather, how climate change can affect species that have timed their life cycle to something that's been going on for eons. It always rains in Costa Rica in the rainforest. Well, for 2 years it didn't, and that's all it took to wipe out that species of toad. Here's one Ron and I talked about with the kids on Fort Huachuca. Our horn lizard. I love horn lizards. When I was a kid in Amarillo, this was my introduction to being a naturalist, was chasing horny toads. Again, a desert environment How are you going to get water in a desert environment? Well, when it rains, you can flatten your body out. You can lean forward. You've got grooves in your scales. The water runs down your back to the corner of your mouth, and you can drink the water you collect off your back. We think rainwater harvesting is something brand new we just came up with in the last 10 years. Horned lizards have been doing it all along. And they are able to do that rainwater harvesting and maximize the water that they're able to get out of a rainstorm. Because if you let that rain fall into the ground, it's just going to soak into the sand and be gone. You got to catch those raindrops before they hit the ground. And this was just discovered really not all that long ago by a researcher over at the Southwestern Research Station outside of Portal in the Chiricahuas. I have to admit I'm an animal chauvinist, but I did throw a plant in here just so we could talk about some adaptations of plants. Again, desert adaptations. How do you keep from losing all your water in that hot desert sun? Well, first of all, you don't really have big leaves. You don't see the big rhododendron type leaves on desert plants. Cactus like the prickly pear, their leaves are reduced to the thorns. And these pads, the stems, have a really waxy covering to them. They're not going to lose much moisture to the hot sun. And they even do a different type of photosynthesis than many other plants. And when we have our Doug Ripley come do his plant physiology talk, he'll talk a little bit about this. But they wait until night to open their pores and do all their photosynthesis work, so they're not doing it in the heat of the day and losing moisture. So again, supremely adapted to dry conditions. And I have to throw this one in. This is not a local example, but it's one of my favorite creatures. We talked a little earlier about the deal struck between hummingbirds and flowers in Ecuador. Here's a trumpet flower. It's a red flower. It's tubular. It's got nectar in it. Looks like it's a hummingbird flower, but look at the size of that thing. What in the world is... Yeah? Well, there's the bird that does it. The sword-billed hummingbird. His bill is longer than his body. Our first trip to Ecuador, I stepped outside the cabin door the first morning and saw one of those big flowers, and I knew we were in the range of this bird. And then I saw a bird kind of buried in the flower, and he started pulling out and pulling out and pulling out and pulling out. Just an amazing adaptation. There's a species of hummingbird in South America that was postulated to exist before they ever saw the bird. They saw the flower. They saw this flower with a curved corolla, and they said there must be a hermit hummingbird around here somewhere, because what else is going to pollinate that flower? They'd never seen the bird before, but they saw the flower and they theorized that the bird was there, and then later they found him. So let's talk about habitats for a bit, because that's one of the things that makes Southeast Arizona so special. It's one of the things that gives us our diversity. We've got so many different habitats here. Satellite view of the Sky Islands. We get a little bit of the Sonoran Desert coming in from the west. You know, the signature plant of the Sonoran Desert is the saguaro cactus, but you notice about 20 miles this side of Tucson, you drive out of the last of the saguaro cactus. What is it, Davis Canyon there? Yeah, you see those first saguaros as you go into Tucson. That's true Sonoran Desert. We have a little bit of the influence, and again, we're getting into that idea that nature is not easily stuck into one category or another. There's a lot of slop over. We get a little bit of Rocky Mountain influence coming down from the Mogollon Rim. We're the last outliers of the Rocky Mountains down here.
Are the Chiricahuas considered part of the
Not really. For whatever reason, it seems like I-10 is the dividing line. Mount Graham is very different than the Chiricahuas. There are lots of species that are really the Sierra Madrean species, the Mexican species. I'll go ahead and throw this other one up there. The Sierra Madrean species seem to get to right about I-10. And that's true whether you're talking plants, reptiles, mammals, all sorts of things are found south of I-10 but not north of I-10. It's weird. Maybe a little different, but you know, the whole reason for the Gadsden Purchase and the reason we're speaking English and not Spanish right now is that they were looking for a southern route for the railroad that wouldn't have to cross the Rockies. They wanted to come far enough south that they wouldn't have to cross the big mountains. And the Gila River south was what was purchased to allow that railroad to happen. But we get...
It had water in it on Monday. Or
Oh, wow.
Tuesday.
Boy, you don't see that very often.
And I-10 across the hill onto water. It looked like it had been running. It was just sitting, but there was a lot of water.
Have you ever heard the story of the German prisoners in Phoenix that escaped from a prison in Phoenix and built a boat and drug it to what on the map said Gila River, and they got to the river and were very disappointed that they weren't going to make it to Mexico floating down the Gila River. So we get a mix of Rocky Mountain species, Sierra Madrean species, Chihuahuan species, Sonoran species, all mixed together here in southeast Arizona. And that's one reason we have such great diversity. They're all cool, but the Sierra Madrean species are so special because many of these are not found anywhere else in the United States except right here in the Sky Islands. The Sky Islands continue on down into Mexico. I did a research project here in the Ajos Mountains, just south of Bisbee. According to my GPS, I was 19 miles from my house in Bisbee, and there were salamanders in the stream that had never been seen in the U.S. Well, wait, I have to amend that, because our reptile guy that talked to us last year mentioned that those salamanders had been seen a couple of times, haven't been seen in 100 years, but were at one time seen on this side of the border. But they're not found on this side of the border now, but they're common 19 miles south of the border in the Ajos. So there's these scattered mountains. And another term for this area is the Madrean Archipelago. And an archipelago is that string of islands. And each of these islands, mountain ranges, they're kind of like the Galapagos in that each has their own particular plants and animals. There are different squirrels in the Chiricahuas than there are in the Huachucas. There are different squirrels in the next mountain range over in Mexico, in New Mexico. You could probably, if you had a really good ecologist, you could blindfold them and drop them into a mountain range here in southeast Arizona, and they'd look around at the plants and animals found there, and they could tell you which mountain range they were in. So they've been isolated by desert for a long time. Mm-hmm.
When I'm looking east, those are the real mountains. And
Yes.
when I'm looking west, is what you
Yeah.
And then
Yeah.
I drive up to Tucson.
Yeah. And then the San Jose's that you see down in the south are actually in Mexico. They're across the line. Yeah. Yeah, that's, we're seeing them right down here, I guess. And really, that's what the mountain looked like. There aren't any borders. There's not a Mexico and a New Mexico when you're a bird or a bat or a plant or a coati. And then we've got these glorious mountains, and they go up a mile high. We're at, you know, what, 4,000 some feet here in the valley, and the top of Miller Peak is over 9,000 feet. So we've got a mile of mountains. And as you go up the mountains, you get through all these different zones. For every 1,000 feet in elevation you gain, it's like going 150 miles north. So we've got 5,000 feet. That's the equivalent of Montana. The habitat on the top of Miller Peak is Montana. The habitat down here is Arizona. And you see it's a little different on the north-facing and south-facing slope. Why is that? Rainfall and temperature, yeah. So within these big, broad categories we're talking about of habitats, There are smaller and smaller categories as well. Here's our classic Sonoran Desert. Get up into the oaks and pines, a little different up there. The high mountains with their limestone. And, even these creeks, they're special because of the limestone. There's enough calcium in the water that you get these travertine deposits. There are some plants that really like that. And there are microhabitats here. There are things that are found right at the stream that you wouldn't find 100 yards away up the hill. There are things that you find under rocks and logs that you almost never see out exposed. So you can take this idea of habitat down to a very, very small level as well. And there's just so many of those things here in southeastern Arizona. You've got the grassland, you've got the scrub, you've got all the way up the mountains. Again, it's a 750-mile trip as you drive up Carr Canyon Road to all these different habitats and the grasslands out towards Sonoyta. Really special area. So that's the reason that we have such a high diversity. I came here because of the birds. There are so many birds here that are not found anywhere else in the U.S., and it has one of the highest diversity of birds of any place that doesn't have a coastline. But there are people here that came here because of the butterflies, because of the dragonflies, because of the plants. And almost whatever discipline you talk about, this area is a real hotbed of diversity because you've got all these different habitats mixed in. And these habitats are not, what's the word I'm looking for? They move around, they change. They're not always the same. Habitats are changing. You can starting out on bare rock. Given enough time, you get a few lichens. The lichen breaks up the rock, forms a little soil, so you get a few annual grasses and things coming in. The longer you go, the more grasses and shrubs until finally you get up here, and if you've got the right rainfall and soil and everything else, your climax community may be a broadleaf oak forest. And that's not to say that the climax community is necessarily better than any of these other communities. There are different plants and animals in each one of these communities. This is probably a good time to take a little break. We're almost at 8 o'clock. Let's take another 10-minute break, and then we'll get into succession and food chains and food webs as we go on. So let's take a short break. Hmm?
Okay, lay the eggs, and then have this to the, so let's say they grow into
Yeah. For throughout the dry season.
They don't have to eat, they just shut down.
Yeah, they just shut down. They go into estivation. There,
And then they just come out
and when it rains, they come out. Yeah.
The playground was so sterile.
Yeah. I went out to Whitewater Draw one time, and it was a dry summer. This was before they pumped any water at Whitewater. Whitewater was bone dry, big cracks in the mud, just completely dry. And we got a 3-inch rain in Bisbee one night, and I thought, I'm going out to Whitewater to see if the play is filling up. And I got out there, and the din of those spadefoot toads, it was so loud you couldn't carry on a conversation. I mean, it was deafening. And I came back and I told Sharon, you got to come out and see this. This is amazing. By the next day, the orgy was over and it was quiet. But there were already ducks and dragonflies and shorebirds. This thing had been bone dry 36 hours before, and there was a whole functioning aquatic ecosystem there that hadn't been there 2 days earlier.
So do any other animals eat the toads?
Yeah.
Yeah.
And I remember you guys did.
Yeah. I had some
I
folks.
remember you guys saying that about you didn't want to be a motel manager.
Yeah.
I'm sorry.
That finally got to us. Yeah, I had some folks I took out on a bird guiding trip the other day, and we went up to Ramsey Canyon. and I probably bored them to death with all my stories. Like, oh, this is where I saw the mountain lion, you know.
Everything you say is so true about how diverse this is.
It's amazing. And, you know, and the nice thing is you can, you know, if you get up early in the morning and go up out on the river and you see all this cool stuff early in the morning, then it starts getting kind of hot and everything slows down. Then you just go up in the mountain canyons and it's cool up there, and the hotter it gets, the higher you go. Yeah.
It's funny, when I was driving here on the campus, I was coming around where the outside exercise course is, around the corner, and there's this coyote there.
Oh, wow. Cool.
I took a couple pictures. I thought, well, I'm sure that my instructor, sorry, that I'm taking a picture of a coyote. I was still mentioning.
Yeah.
He was just chewing. I've not had a chance to get that close to a coyote because he was just literally right off the road, just chomping on mesquite pods.
Yeah.
Very fun. And I have him on my property. That's another reason why
Yeah.
I learned, because when she saw property, it's like,
Yeah.
oh, we're being overtaken by all these things.
And something I didn't talk about, and when I talked about niche, you know, there are some creatures that are so specialized, you know, they only feed on this plant, or they only do that, and they are easier to disappear than something like a coyote that is so flexible and so adaptable. If they're in the wilderness, they'll live in the wilderness and they'll eat rabbits and squirrels. You build a farm out there, they say, fine, I'll eat your chickens. You build a subdivision out there and they say, great, I'll eat your house cat and I'll eat your garbage, you know. And they'll live wherever, you know, and they just make do with what they've got. And because of that, they'll probably outlive our species. You know? Yeah. They just,
Which is very healthy here.
you know, give them a chance and they'll do whatever they need to do.
So if I wanted to learn about, I was very interested in the plants. Here I have incredible variety of plants on this bag, and I just feel so fortunate. Because it's incredible, but I want to learn about them. I want to learn what they are, if there's any types of purposes that are used, native, American.
Yeah. There's the fellow who's going to do our plant unit. It's plant physiology and then plant ecology, and he talks about the different habits. He's also the president of our local native plant society, and they meet once a month and they have programs on various aspects, and they have field trips and things, and some really knowledgeable people. You know, if you just took a bunch of pictures on your phone or whatever and went to one of those meetings and went through them with somebody, they could identify most of them. And there are some folks, you know, one of the things that I didn't mention that I ought to is I also want to do some kind of continuing education, you know, after this class is over, after we do the 11, you know, not every week, but maybe once or twice a year, get a special speaker on some really cool topic and just have, you know, continuing education opportunities. You know, you can come and somebody who could speak on medicinal plants and all that would be a good person to have.
Have you been to the San Pedro house? I gotta go. Okay, well, I was going to say there's a lot of books. Okay, yes, I
Yeah.
did too, and field guides.
And the plants, the landscaped plants around the house, a lot of them are labeled too. They've done a really good job of landscaping the house. You know, I was looking through some old slides the other day of our hummingbird banding, and I had slides from like 10 years ago, and I looked at the San Pedro house, and it was just Johnson grass, you know. And now there's so much landscaping and those labels, you know, if you can walk around and say, oh, that's it's a good way to learn the plants.
Yeah, so they were successful in eradicating Johnson.
They didn't eradicate it. It's still, you know, and it's one of the hardest plants, one of the hardest invasives to get rid of. But right around the house, there's an awful lot of native landscaping where 10 years ago there was nothing but, they made her. And there's been volunteerhood at the Daughters of the American Revolution and some other volunteers that have put in hundreds of hours out there working on the plants. In, you know, not the most hospitable of climates, and there's snakes, and it's, you know, they've really done a great job.
Is the Johnson grass that really tall stuff?
Mm-hmm.
Well,
There's several tall, yeah.
Does anyone eat Johnson grass so white?
Some birds do, yeah. Yeah. They may not eat it until it dries a bit.
Plus, we don't usually get this much rain. This is
Yeah.
highly unusual.
Okay, well, where do you see the light? Nobody.
Yeah, don't think it's like this.
We moved here in July of '88, and the first 6 weeks we were here, it rained every day.
Yes.
And I thought, this is great. You know, Car Canyon Falls was flowing, and I thought, man, this is incredible. And I don't think we've had a year like that since.
Yeah, it seemed like it was a long.
Yeah, and when it'll stop soon, and then that'll be it.
Yeah, or we may go.
And
And
then you go, when's the last time it rained? Oh, a month, 6 weeks, I'm not sure.
yeah, we can go 2 or 3 months. You know, April and May, it's not unusual for us to have zero rainfall in April and May.
That's the thing, the winter rain is actually more important because it's a slower, steadier rain and so forth. And that's really been hurting. No snow in the mountains.
Yeah, last year it seemed like there wasn't.
Well, it didn't even get that cold.
A lot of my plants, my pot plants. So Sabo is bird rehabilitation or what is it?
No, we do science and education, generally around birds, but you know, nature in general and all. Hummingbirds have been the focus of most of our research in the last several years. We do hummingbird banding at the San Pedro and another site, and have been doing that for 19 years now.
So you do education, you on site, you go to somebody's site or you?
We do workshops and tours, and occasionally I go into the schools. I talked to someone in Douglas the other day about coming into the school and doing. I love teaching kids about nature, and I miss that. So yeah, oh they do, yeah. That's one of the things. One of the books I was reading, preparing for this class, was saying, you know, regardless of anything else we do, if the next generation doesn't care about nature, it's all for nothing, you know. If and you know, all these kids that never go outside and chase horny toads and stuff
Exactly.
are you know.
I am always bringing something to class. They're always like, Mrs. Happ, what's in that jar? Oh, we have a 2-day catch and release.
I love going into the classroom, and they've got, you know, tadpoles in the aquarium, and they've got, you know, a box turtle or whatever. It's just.
Got this, and well, he didn't make it because he cornered me in my closet, but he is really a nice specimen. He is good.
Okay, let's see if we can get through the rest of this.
Really long neck. So is it the way it curls up its tongue, the way other hummingbirds do, is it the same way?
Yeah. And that's the one that is relatively common around Quito, and nobody has ever seen the nest or a baby. That's what I want to do. So nature is always changing, and a climax community is not necessarily the ideal situation for everything. So what sort of things, if you've got a big stand of trees there, what sort of things could change that? What sort of things could knock it back in succession? Fire. Fire is a big one, yeah. Development, yeah. It's hard to come back from development, but fire is a biggie. And, you know, here in our mountains and in the Southwest, we've certainly had our share of fire in the last few years. And we're learning more and more, we're accepting more and more, that fire is not necessarily a bad thing. Now, it's a bad thing if you've got a cabin in the woods and you've got trees all around it, you're going to lose that cabin. But for the forest in general, it may not be a bad thing. And we've had some big fires here in the last few years. And the difference between that big inferno that I showed you in the last slide and this fire that's creeping along the ground and burning up the leaf litter may be temperature or humidity. I went through a fire behavior school when I worked for the Nature Conservancy. And in those days, we had these slide rules and charts and everything. But you can look at the temperature and humidity and the moisture in the fuel and the slope and all of these sorts of things and plug that into a computer these days, and it'll tell you you're going to get 4-foot flame lengths and it's going to move at 3 miles an hour. And those things change over time. So when you get these big fires like we had in the Huachucas and the Chiricahuas, they go on for weeks and weeks. There are some areas that burn very hot, and there are some areas that burn very cool. Some areas you can't even tell there was a fire, and then other areas it burns right down to mineral soil. And in many places, we've already seen this. Within just a few weeks of the fire, you go in and things are poking their greenery up, right up through the ashes. Those ashes have sent a whole lot of fertilizer and nutrients back into the soil. They've opened up the canopy to the sunshine, and things are really happening. We've seen here in the Huachucas, and again, it's terrible. We lost dozens of homes in the Monument Fire. And when the fire was happening, again, going to our hummingbird research, we were banding hummingbirds on the river. All of a sudden, we get all these mountain hummingbirds down on the river. Their habitat was gone, and so they came down to the river until it began to green up again. The next year, we had not very many hummingbirds. The year after that, we had even fewer hummingbirds, not only at our site on the river, but at many of the feeding stations around the mountains, and everyone's saying, oh, what's happening? You know, the hummingbirds must have been wiped out by the fire. No, look up on the hillsides. The wildflowers are going crazy up there. The hummingbird adapted wildflowers are just carpeting the meadows where they've got all that sunshine, they've got all that rich soil. They're going crazy, and that's where the hummingbirds are. They're up on the flowers. So fire may not necessarily be a bad thing. And again, when we talk about good and bad is when we get into trouble. Fire is a natural process, and it's necessary. It's certainly very necessary in maintaining the prairie. Here's a chart of some of the forest and wood. You can't read all of this, but looking at tree ring data, going back several hundred years, they're able to say that the natural fire period in our Sky Islands is about every 8 to 15 years. In pre-European times, about every 8 to 15 years, there would be a mild fire sweep through the mountains. generally clean up the understory, clean up some of the brush. Sometimes it would climb up into the canopy and be a damaging fire. But in 8 to 15 years, you're not going to get a lot of fuel buildup. That goes, you know, from 1600 to 1900, pretty much right along the line. 1900 happens, Smokey Bear shows up, we start fighting forest fires. All of a sudden, instead of a 15-year fuel load on the ground, you've got a 100-year fuel load on the ground. And when you do get that fire that finally is going to happen, and it's not a matter of if you're going to have a fire, it's a matter of when. It will happen sometime. And when you get it and you've got a heavy fuel load on the ground, it's going to be really severe. And in the Monument Fire, we had days when it was over 90 degrees, 40-mile-an-hour winds. There was one day they recorded 0% humidity. I didn't know you could have 0% humidity. And the fuel moisture, it had dried out for weeks ahead of time. In those conditions, there's nothing we can do to fight a fire. We might be able to steer it a little bit. We might be able to kind of save a building here or there. But we got to wait for the Mother Nature, and we got to wait for the rains to come to stop a fire like that. So, you know, around the country in the prairies, a fire, you know, every few years is needed in the prairie to keep the brush from encroaching. The only place we have really long fire periods is up here in the Pacific Northwest. You know, 500 years to have a fire up there. But again, 500 years in the life of a mountain is just the blink of an eye. But a prairie needs fire to keep to keep the mesquite and all from coming in. You ever noticed how different the grassland is on Fort Huachuca versus down towards Hereford? You know, all the mesquite down towards Hereford, Fort Huachuca, lots of grassland. The difference there is fire. Fort Huachuca has had fires in part because they had enough grass to carry a fire because they never had heavy grazing. You take a grassland, graze all the grass out, you do away with fires. In fact, driving towards Sonoyta, there's a sign that grazing prevents blazing. And it does, but what they don't tell you is that blazing is a good thing. And grazing, preventing that grazing is changing that habitat. And again, good or bad. There are some things that like mesquite. There are some things that like grassland. It's a different habitat. Rustler Park in the Chiricahuas will never look the way it did 5 years ago. And I loved that place 5 years ago. In my lifetime, it will never look that way again. But it's different. And there are different things happening there now than were 5 years ago. It's not better or worse. It's just different. There are also some critters that can change their own habitat. Keystone species like the beaver. The San Pedro went without beaver for 100 years, and then they were restored to the river. People call it a reintroduction, but I like to call it a restoration. They were brought back to the river, and they've changed the river. They changed the way the river moves. They changed the plants that are there. Prairie dogs are another keystone species. They change the habitat around them. We've wiped them out in southeastern Arizona. They've just started restoring them over at Empire Cienega. But they're another keystone species. And I'll talk more about both of these during my mammal talk. All right, the San Pedro River. 1987, when it was first acquired as public lands. Here's a picture of the river. Look at all those cows. Here's what the river looked like. Here's what the river looked like. Here's the exact same point 4 years later. Look at the change in that river in 4 years after you took the cows off. And the cool thing about it is the BLM was smart enough that they did monitoring early on what was there when they got the property. And then 4 years later, they came back and said, what's there now? And the fellow who was the ornithologist there at the time, Dave Creeper, published a paper that I'll go through real quickly. Counted all the birds of 61 bird species, 26 increased significantly and 19 decreased. So there were winners and losers, but more winners than losers. and they went from having 100 birds per kilometer to 221. The bird population doubled on the river in 4 years once you took the cows off. So, and the largest increase happened in open cup nesters, migrants, and insectivores, and the Chihuahuan desert scrub species didn't change much. So it's really interesting to see the response to an area once the management is changed. And that gets us to the idea of food chains and food webs. Well, I've been going into first and second grade classes for years and talked about, who's going to eat this leaf? A plant is the only thing that can make food from the sunshine. And who's going to eat this leaf? Well, the caterpillar eats it. Now who's going to eat that caterpillar? Who's going to eat that bird? And who's going to eat that snake? And just a simple line. But again, nature is more complex than we probably can understand. There are all sorts of things going on out there in a food web, much more complicated than a simple moving up the line. But it basically is taking the plants, which are the only thing that can take that energy from the sun and put it in a usable form, and then measuring the way that energy moves through a system. From the plants, through the small critters, up to the medium predators, and the big predators up on the top. And this is more graphically shown in this kind of a pyramid, because every one of those creatures is using some of that energy too. From all the energy produced by that grass, all these grasshoppers are using some of that energy, but they're not using all of it. Some of it is stored in their body, so the next consumer is going to get that energy, but it's going to use some of that energy before it goes up to the next consumer. So as you go higher in the pyramid, there are fewer and fewer inhabitants. There was a book several years ago called Why Big Fierce Animals Are Rare. And part of it is just that food pyramid. You can't have as many mountain lions as you do deer. You can't have as many shrews as you do grasshoppers. Just wouldn't work out. You've got to work from the bottom up. But what we're learning in recent years is that the health of the habitat is really managed from the top down. You've got to have that big predator up there to keep these numbers in line so that these numbers don't get out of line. If there were too many shrews and they ate all the grasshoppers, the grass would get much bigger. That's maybe not the best example to give. One wants their grass to be big, but too many owls eat all the shrews, then there's more grasshoppers. That's where the problem comes in, yeah. But there's rarely too many owls. Usually the problem is that the big predators are wiped out. And you probably can't even see this. This is a book called Where the Wild Things Were by Will Stolzenberger. I worked with him at Nature Conservancy. This is a wonderful book about the role of big predators in habitats and in ecology. And he gives example after example of how important those big predators are. Everything from starfish and abalone and sea otters and killer whales and all sorts of examples all along the way. One of the best known ones, and you may have heard about this, I think it was in Silent Spring and all sorts of things, the Kaibab Plateau up on the north rim of the Grand Canyon. Beautiful area, and it's always been such a special place. Even back in 1906, they decided this is a wonderful place. We're going to declare this area a game preserve. And so they declared the Kaibab Plateau a game preserve. So in those days, the game managers thought, well, we got good animals and we got bad animals. We want the deer, we don't want the predators. So over the next 20 years, they killed off 6,000 predators in the Kaibab Plateau. They killed 800 mountain lions. They killed the last 30 wolves in the Kaibab Plateau. The deer population went from 4,000 to 100,000. And for a while, people thought, this is great. You know, they were driving out there looking at the herds of deer. Isn't this wonderful? And then they noticed the browse line getting higher and higher on the trees. They noticed the deer weren't looking too good. There was even, Zane Grey wrote a book about this. There was even a plan to herd the deer off the plateau and down into the canyon and up to the other south rim of the canyon, which sounds pretty crazy to me. And the cowboys quickly learned you can't herd a deer on horseback. Didn't work very well. But what happened, 1924-25, we had hard winters. 90% of those deer died. It was a terrible thing to watch, and people realized that maybe getting rid of all those predators was not the best thing to do, not only for the habitat, but for the deer themselves. Too many deer is not necessarily a good thing. And we're seeing that back east right now. You know, again, one of the examples that was quoted, one of the studies that was done was in Rock Creek Park outside of Washington, D.C. The big predators are gone, and the deer are eating everything that's there. And how do you deal with that?
I'm just trying to pick 6,000 predators, 1,000 of the lions and the wolves, and then probably a lot of coyotes.
Probably mostly coyotes. You know, coyotes are always one of the main predators, but that probably includes foxes, golden eagles, bears, badgers, you know, anything. And it went back to, this is 1906, but it was that, you know, good animal, bad animal. Let's get rid of the bad animals so we can enjoy Bambi. Without really thinking about the way everything is interconnected there. And one of the big experiments in the last few years has been the return of the wolf to Yellowstone Park and the Northern Rockies. The last wolf in the Northern Rockies was killed in the 1930s, I think, in Montana. For 70 years, there were no wolves roaming the Northern Rockies up until you got up into Canada. And I worked at Yellowstone Park right out of high school. I was washing dishes, but I was in Yellowstone Park back then. And to me, it was just such a wonderful place. You know, this huge park. What could be more natural than Yellowstone Park in the 1970s? Well, there was a big piece of the puzzle missing, and that piece was the wolves. And it was 1995, they brought the wolves back to Yellowstone. And they have spread throughout Yellowstone. And they have changed Yellowstone Park, and they've changed it in ways that nobody anticipated. They found that the wolves are moving the elk and the moose. They're eating a lot of them, but they're also keeping them moving. They're keeping them from just camping out down in the creek beds. And when the elk and the moose are no longer spending all their time along the stream side, all of a sudden you've got willows growing again in places where the willows hadn't grown in many years. And once the willows start growing again, the beavers come back. And once the beavers come back, they build dams, and you got the ponds. The water soaks back into the bank and comes back out at dry times. The water stays a little bit longer. The ponds provide different habitat. All of a sudden, you've got cutthroat trout coming back in valleys where they hadn't been seen in years. Who would have thought that you could manage for cutthroat trout by introducing wolves? Who would have made that connection? And again, nature is more complicated than we give it credit for. And there's all these little things that are happening. The wolves are big predators. They're culling the elk and even buffalo. You know, these wolves are able to, as a group, to kill generally a sick or injured buffalo. The elk and the moose, they're taking care of the sick and the injured ones. They're making the herd a lot healthier. They will also outcompete and kill coyotes. And the coyotes were killing the foxes. So you get rid of the coyotes, more foxes coming. More foxes, fewer mice. Fewer mice, more seedlings, more songbirds. This cascade, they call it a trophic cascade. When you change the top of the pyramid, there's this cascade effect all the way down. And the loss of the big predators is one of the big changes to the pyramid. Here's, again, it changes the dynamics. Having the large predators, you've got more open area, mix of large and small predators here. One of the examples that Will mentioned in his book I found really fascinating. I'd heard of the Yellowstone thing. It's pretty widely spread. And of course, wolves are very controversial. And he points this out. One of the problems with the big predators, with being an advocate for big predators, first of all, there's not very many of them. They're at the top of the food chain. Secondly, they're hard to study because there's not very many of them. They travel great distances. They're a difficult group of animals to get any real hard data on. And they've also been maligned for so many years. And we're seeing this today in Cochise County as they talk about designation of Cochise County as critical habitat for the Mexican wolf. I don't think we're ever going to have Mexican wolves roaming in Cochise County. There's just too many people here. But the hysteria that comes out, oh, we've got children that are waiting on school buses in the morning, and they won't be safe if there's wolves out there. In the history of man, there has never been an attack on anybody by a Mexican wolf. I mean, 10 people are killed by vending machines every year, but Mexican wolves are not a threat to people. And yet, it's the big bad wolf syndrome. We don't want wolves out there. Our children will not be safe. An example that Will mentions in the book is Zion National Park. How many of you have been to Zion? It's a beautiful park, beautiful geology, beautiful winding stream and all, but it's ecologically it's not a very healthy park. There's a lot of deer there, but there's not a whole lot else, and the park is not in great shape. A couple of fellows studied the park and they were wondering what's going on here. What's the problem? And they noticed that even though there were quite a few deer, they were not seeing mountain lion tracks. They were not seeing evidence of mountain lion kills. Probably because there's just so damn many people in Zion that the mountain lions don't feel comfortable. Although certainly the mountain lions in California seem comfortable around people. But the mountain lions in Utah, for whatever reason, are not in Zion. Yeah. But the next canyon over from the main Zion Canyon, just over the ridge is another canyon very much like this, and the researchers went there and they walked the stream and they're seeing mountain lion tracks all along the stream, and they're seeing other things as well. So they went over and did a quantitative study, looked at everything that was there. In North Creek Canyon, just on the other side of the divide from Zion, they found a canyon that has 47 times as many cottonwoods growing along the stream because they don't have all the herbivores there. There's 3 times as many lizards, 5 times as many butterflies, 100 times as many toads, 200 times as many frogs, and an infinity of cardinal flowers and asters because they couldn't find any of these nice herbaceous flowers at all in Zion, and they found them in this other canyon. And the difference between the two, as far as I can tell, it's not geology, it's not rainfall, it's not soil. The difference in those 2 canyons is this guy, keeping the deer population down and changing the dynamics there. So, you know, people ask me why our Sky Islands have such great diversity, and there's a lot of reasons to point to. The diversity of habitats, the mixing of the big biomes we talked about, the Chihuahuan and Sonoran Desert. But part of the reason is we've still got predators. We've still got lions in those mountains. We don't have wolves anymore here. We don't have grizzly bears anymore, and we did at one time. So there are some big predators missing. But we do still have lions, and they're big enough to take the biggest prey animals we have, the little Coues white-tailed deer. And we do still have, you know, a good good population of them out there. So they help keep the deer down. By keeping the deer down, that keeps the plants up. Keeping the plants up, all the things that depend on those plants, from butterflies to toads. The streams are healthier, and when the streams are healthier, you've got frogs and toads. The whole thing is kept in check by the big guy at the top. That trophic cascade can be a killer. So we're lucky here that we still have most of the pieces. Some of the pieces are being restored. The beaver coming back to the San Pedro River, the prairie dogs coming back to Empire Cienega. We still have most of the major pieces here, although again the wolf and the bear are gone. And I don't think anybody is seriously talking about bringing grizzly bears back to southeast Arizona. First of all, the grizzly that we had, the Mexican grizzly, is extinct. And that's the other thing. Extinction is forever. Once they're gone, they are gone forever. It's the same bear that occurred in California as well. It's the bear on the state flag of California. It's the reason you've got the UCLA Bruins and the Cal Bears, but the grizzly bear that was in California and in Arizona is gone. It was smaller than the northern grizzlies that we see up in Yellowstone. And there are a couple of kind of general rules of ecology that usually the further north you go, the larger the animals are. A deer in southeast Arizona, 100 pounds, 125 pounds. You go up to Minnesota, a white-tailed deer is 300 pounds. A moose in Yellowstone is a big, impressive animal until you see a moose in Alaska. A grizzly bear in Yellowstone is an impressive animal until you see a grizzly bear in Alaska. So the further north you go, you generally have larger body size. That helps them conserve body heat. They have less surface area for their mass, so they're able to conserve the heat. Another rule of thumb, a lot of times the southern animals, and particularly ones in dry, hot climates, have larger extremities, like the big ears of a jackrabbit, as opposed to the little ears of snowshoe hare up north. That helps dissipate the heat a little bit.
Have you noticed that we don't see jackrabbits?
They are really cyclical. A few good years, and they have that strategy that kind of like the toads, and we'll talk about this some more in the mammal unit, but they have a strategy where they can reproduce very quickly when conditions are good. But when conditions are bad, they drop right down.
Like 2 years, 3 years, I haven't seen jackrabbits.
Yeah.
Again, I go up to Karchner a lot.
Yeah.
I used to call them dog rabbits all the time because they were big. And I haven't seen jackrabbits in quite a long time.
We did a bird banding project over at Chiricahua Monument several years ago, and we had to have the nets open at sunup. So I went over and camped for a few times, but I never sleep quite as well on the ground as I do at home. And so I thought, it's just as easy to get up at 3:30 in the morning and drive to the Chiricahuas as it is to camp out the night before. So I started leaving Bisbee at 3:30 in the morning and driving to the Chiricahuas. And the only way I could keep myself awake on the drive over there was by keeping score between the jackrabbits and the cottontails. And sometimes by the end of the drive, it would be 50 to 49, jackrabbit. And there's have slightly different habitats. There are places where I would see jackrabbit after jackrabbit, and then I'd drive out of the jackrabbits and I'd see cottontail after cottontail and all. It was interesting. And again, over the years, some years the numbers drop precipitously. And it's not a scientific monitoring. I'm counting the rabbits as I drive along the road and try and dodge them so I'm not hitting them on the highway. And some years, in really dry years, they seem to concentrate right along the road where there's maybe a little more moisture and a little more greenery. But they can, again, if we have a few good years, they may bounce back, or they may be an example of one of those species that is just changing. We've seen examples here. The Gamble's quail is more of a desert quail, and the scaled quail is more of a grassland quail. 20 years ago when we came here, there were scaled quail all out in the valley. We had scaled quail at our feeder in Bisbee. And over the years, the scaled quail have kind of pulled back. The Gambel's quail have expanded their range. The desert has encroached on what used to be grassland. It's gotten hotter and drier. That's good news for the Gambel's, bad news for the scale. Again, there's winners and losers in every scenario. But we're seeing a change in the bird population according to the climate. And that's one of the things that this phenology network can help monitor. There was just a report that just came out in the last week from the National Audubon Society that nearly half of our native birds are going to have a problem with climate change. We're going to see birds disappear from places where they used to be common. We're going to see birds showing up in places where they never showed up before. There are going to be winners and losers. There's going to be those that adapt. There's going to be those that don't. But as the climate changes, we're going to see changes in birds. And again, everything is connected. Everybody knows that the birds need the forest. That's easy enough to understand. But sometimes we forget that the forest needs the birds too. Those birds are eating insects, they're dispersing seeds, they're doing all sorts of services to the forest. And if we lose a species of bird that is, the seed dispersal unit for this particular plant, that plant is in trouble unless something else can come along to replace it. And we talked about the small habitats of the underside of a rock or a log. Particularly with birds, we've got to consider ourselves just part of the much bigger picture. In another 2 or 3 weeks over in the Sulphur Springs Valley, there may be Swainson's hawks still in the valley that will end up spending the winter in Argentina. At the same time, there are sandhill cranes that nested in Siberia arriving in the valley. You could have a bird from Siberia and Argentina in the same field in the Sulphur Springs Valley at the same time. And that energy is moving back and forth from the Arctic to Argentina. And so we're part of a bigger picture. You can't just put a bell jar over southeast Arizona and consider it as one particular unit. It's all connected, particularly where the migratory species are concerned. So there's a lot of changes coming. There are all these connections that we maybe don't even think about. I see it on the San Pedro River in the spring. We do regular walks on the river. And I always thought it was kind of cool that just about the time all those tent caterpillars get on the cottonwood trees on the river, and they'll just be tent caterpillars everywhere you look. And you walk along and the frass is just falling out of the trees. It's like it's raining. And people say, oh, it's terrible. They're going to kill all the trees and all. Well, they don't kill the trees. And not only do they not kill the trees, all those millions and millions of caterpillars are there right at the time when the waves of southern migrants are coming up the river. Millions of songbirds coming up the San Pedro River, and they get there when the caterpillars are eating the leaves. Those songbirds can't eat leaves, but they can eat caterpillars, and they do by the millions. And so that's a connection. They get here, they get to the filling station just as the gas pump is full of caterpillars. What if that were off by 2 weeks? What if the caterpillars came 2 weeks earlier, the birds came 2 weeks late, and they missed one another? Have you ever had the experience where you've got a route that you drive a lot and your gas tank's on empty and you say, oh, I'll fill up at the next town. There's that little gas station I always stop at. And you get to that next town and the gas station's closed. And you go, oops, yeah, can I make it to the next one? We're going to see birds doing that,
Did they ever spray for caterpillars?
People ask us about, why doesn't the BLM spray? They've got so many caterpillars. But again, the caterpillars are a natural thing. And they'll strip all the leaves off the trees, and then 3 weeks later, caterpillars will be gone, the leaves will come back.
No, the reason I asked
Yeah.
that is I come from New Jersey. They spray the whole
Yeah.
state.
Yeah. Well, and they were worried there about, was it the gypsy moth or something there? But what we're learning is, again, that anything you pick at is connected to everything else. We certainly saw that, the DDT that we sprayed for mosquitoes. Nobody likes mosquitoes. Let's get rid of them. We'll spray DDT. Don't think about the fact that that DDT is going to be eaten or by insects, and those insects are going to be eaten by little fish, and those little fish are going to be eaten by bigger fish. And as you go up that trophic pyramid, it concentrates and concentrates, and what started with 1 dose per minnow down here on the bottom is 10 doses per sunfish, and is 100 doses per big bass. And then the osprey comes along and eats 10 big bass, and he's got 1,000 doses in him. Or her, and she lays eggs with thin eggshells because of the DDT. Peregrine falcon the same way, and it took us years to figure that out, that we thought we were just getting rid of the mosquitoes. We didn't dream we were getting rid of bald eagles and ospreys, but it's that unintended consequence when we go to meddling in nature. And at the bottom of all of that is just an understanding of ecology as much as we can understand it, just understanding the idea that everything is connected, and generally everything tends to work pretty well the way it's working, and as we try and change it, often it doesn't work very well. Now, we talked about the role of big predators in controlling deer numbers. Why doesn't deer hunting do the same thing? Everybody knows there's lots of deer hunters out there. What's the difference between a deer hunter and a jaguar, a mountain lion? Okay, that's part of it. A lot of hunters are going for the biggest, healthiest buck they can shoot. And from a wildlife management standpoint, animal husbandry standpoint, if you were a rancher and you routinely killed off your biggest, healthiest bulls and didn't kill the scrawny little ones, your herd wouldn't look very good a few years down the road. But what else besides the fact that they're taking the big, healthy animals? What? Yeah, if they're not taking does, you get a skewed sex ratio. And hunting season is for a few weeks or a few months a year. And that mountain lion is hunting day in and day out. And he's taking the sick and the old and the injured. Yeah, he takes a healthy animal every now and then, but it's a lot easier to take the sick, old, and injured. And they're making the herd stronger by doing so. And they're not only making the herd stronger, but they're protecting everything that herd is feeding on. So it can make a difference. You know, I'm glad we have deer hunters. I'm not a deer hunter myself. I'm glad there are people that do it because it does help. But it's not a replacement for the big predators. Yeah?
So, if the game hunter goes to the large trophy hunt, so isn't it also given an opportunity for, you know, in that type of species where they fight for, during the rut season, they fight for the right to, you know, move the rest of the herd.
Mm-hmm.
By killing those larger animals, the older, the one that's, you know, made his name in that herd, it's giving the opportunity for the younger male deer to
Yeah, you take out that big alpha buck, and suddenly the one who hadn't had a chance to reproduce before has a chance to reproduce, and that gives us a greater gene pool. Yeah, that's true, and that's a good thing.
I was just going back on that coyote antelope thing. My husband has this thing about wanting to join one of those predator hunts, you know, to shoot coyotes. Yes. So tell me that the antelope babies, they're diminishing the herd, blah, blah, blah. And I'm not so sure I believe that, but I know that there's Fish and Game has people that go out and shoot them. So what do you think about that?
Well, yeah, again, the predators, you and I, our tax dollars are going to kill predators every day by the thousands because there's still the perception out there that the predator is the bad guy. And if you're in a situation like we talked about with the cowbirds and the rare black-capped vireos, you got a rare species and that predator is taking their young on a regular basis, then maybe some sort of intervention is needed. But on the other hand, most of a coyote's diet is going to be rabbits and mice, and those rabbits and mice are eating a lot of the grass that those antelope are going to want. So a grassland without coyotes is not as healthy as a grassland with coyotes, and pronghorns depend on healthy grassland. So big picture wise, that coyote is helping the pronghorns, but he's taking a calf every now, or taking a fawn every now and then, and that's a hard thing to watch. And when you've got only a small herd to begin with, you have to weigh whether the loss of a few fawns is worth the year-round management of the grasses. And those are tough decisions. Game and Fish, look at their name. They are in the business of hunting and fishing. And they would, and their money comes from license fees, their money comes from ammunition taxes. They're in the business of providing sport for hunters and fishermen. And one of the ironies is that even though less than 4% of Arizonans hunt, Game and Fish is in charge of all of our wildlife. And they do have endangered species branch, and sometimes, particularly where the fisheries are involved, the guys at one end of the hall are trying to save these rare, tiny native fish, while the guys at the other end of the hall are stocking bass and catfish and trout into every stream they can find, which is the biggest threat to those native fish that these guys are trying to save. It's kind of a schizophrenic organization, and it's the same in almost every state, because again, their funding comes from sportsmen's dollars, but their responsibility is for all wildlife, and sometimes the management goals of a hunting group and the management goals of an ecological group may be very different. So I don't envy them in their charge, because they're supposed to take care of our wildlife. But, you know, we saw this in Tucson. They brought the bighorn sheep into the mountains there in Tucson, and they dumped these sheep out there that were drugged, and all of a sudden found themselves in an unfamiliar place, and they didn't know what to eat or where to go or where to drink, and they were confused and wandering around, and they got eaten by the resident mountain lions. No one should have, I mean, no one was surprised by that. But Game and Fish's answer is to take out the mountain lions, who had lived there all along and had this buffet dumped in their lap, but are expected to not eat it. But again, we get back to the cowbirds, and there are so few sheep that we can't really afford to lose very many. They got down to one ram, and it's hard to have a successful, yeah. So, and as much as we talk about saving all the pieces, extinction is a natural part of the process too. And although the extinction rate today is many, many times the background rate, animals have been going extinct all along. And I have real mixed feelings about the California condor project up in the Grand Canyon. They're magnificent birds, and I would hate to think that the condor disappeared during my lifetime. But on the other hand, if they're going to require supplemental food forever, then are they really a wild functioning part of the ecosystem?
I think they just require a lack of lead and
well, there again, yeah, are there that many big animals dying out there that don't have lead in them? Are there that many big, are they a Pleistocene relic? Are they an animal that did really well back when there were huge grazing animals and whales on the California coast, but the time has passed them by? There are times when I think we have to just say, well, you know, maybe this animal is one that's not going to make it in the wild anymore. And another thing is that we have to accept the fact that we have changed the world more than every beaver and prairie dog out there. You look at this planet from space, and humans have changed it in incredible ways. And again, it may not be good, it may not be bad, it's just different. We may have to accept that house sparrows and starlings and pigeons are going to replace some of the wild birds that lived before we built our developments there. And we talked about development as a force of succession, but once a house gets built and a road gets built, it's never going to come back to that other form as well. So.
Well, if you talk about Zion, the last time we were there, I wasn't sure we were on the correct road. They have 5-bedroom houses all along that road going into Zion, coming in from the west.
Yeah.
It's total civilization coming into
They have this. They're calling this the Anthropocene. The new epoch is basically, we are the biggest influence on the planet right now, and for better or worse, we are changing the planet in ways that a lot of things just can't keep up with. So I hope over the next 11 weeks we will hear some of these same themes over and over again, and I hope you got a bit of an overview tonight of at least my philosophy of kind of the way things fit together and some of the things to look for. And as you could probably tell from my teaching style tonight, I like to tell stories. And I think, you know, when you're taking a walk, leading a walk on the river or up in the canyons or whatever, if you can tell a story, and if it's from personal experience, all the better. But, you know, if you want to talk about the Yellowstone wolves or want to talk about, you know, some of these really interesting stories of the way things are all connected, that means a lot more, again, than just walking down the trail, reciting the names of every plant along the way or every bird you encounter. The way they interact with each other is really what is important. Yes?
A comment and question. First, I understand that fishing law in California saved Moon Lake because they had passed laws that protected fishing streams, and they were taking water from the stream within Moon Lake, and they had to stop.
Yeah.
But and the other question is, thinking about top predators, would a jaguar and a mountain lion, they effectively be in the same niche?
You know, I heard a talk about jaguars, and they were explaining how they were slightly different than mountain lions. I think in areas where there are both mountain lions and jaguars, the lions tend to hunt in the daytime and the jaguars hunt at night. If there are no jaguars around, the lions will hunt at night, but they don't want to encounter a jaguar. So I think that's the difference, in that they're not direct competitors because they're isolated temporally by the time they hunt. But you got to wonder, most of these mountain lions have never seen a jaguar before, and how do they know? And you know, they're not going to see a jaguar now, but they're walking down the creek and they sniff that pile of droppings and they go, "Ooh, there's a new guy on the block, and he's somebody I need to stay away from." I've thought about that with the Grand Canyon. You know, golden eagle's out there soaring around. He's been the biggest guy in the canyon for 100 years, and all of a sudden, who is that? You know, who's that guy? And they had some golden eagles kill California condors. So some of these animals that have never encountered these other animals before, is it instinctive, like with the cowbirds knowing who to mate with, or is it a learned behavior that they get chased by? They're used to everybody running away from them, and they see a jaguar and he doesn't run away from them. Do they realize that I'm not the big kid on the block anymore? I don't know. It's an interesting idea. Yes?
I just make a plug for National Public Lands Day. It's 2 weeks from tomorrow. It's a national event all over the country. And our organization, Friends of San Pedro River, we're going to do an event out at Fairbank, which is a ghost town. And we're going to do stuff inside the schoolhouse, outside the cemetery, all kinds of volunteer opportunities for anybody